Let us study applications of determinants. Equation of straight line. If a line passes through points x1, y1 and x2, y2, its equation can be written in the determinant form as x y1, x1 y11, x2 y21 is equal to 0. Let h, k be a point whose locus is the straight line passing through x1, y1 and x2, y2. Then area of triangle formed by these points will be 0 because they are collinear. Therefore, the determinant formed by replacing x is equal to h and y is equal to k equals 0. On replacing h, k by x, y in the equation, we get the equation of line in general form. Let us have an example. In ABC, find the equation of angle bisector of A given that angle bisector will divide the opposite side in the same ratio as the ratio of the sides containing the angle. Let us have the solution. We know that BD by DC equals C by B. Therefore, BD equals KC and DC equals KB. Coordinates of D can be found using the section formula. The coordinates of D are cx3 plus bx2 divided by b plus c, comma cy3 plus by2 divided by b plus c. Therefore, equation of AD becomes xy1 x1 y11 cx3 plus bx2 divided by b plus c, cy3 plus by2 divided by b plus c 1 is equal to 0. Now, using the property of determinants to break the determinant in two forms, we get the required determinant, which is the required equation of a straight line. Solution of system of linear equations can be found out by two methods, using determinants and using matrices. Consistent system. A system of equations is said to be consistent if its solution, one or more, exists. Inconsistent system. A system of equations is said to be inconsistent if its solution does not exist. Using determinants, that is Cramer's rule, consider the system of equations a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, and a3x plus b3y plus c3z is equal to d3. Then determinant delta can be formed by the coefficients of x, y, z, and delta x can be formed by replacing the coefficients of x by d1, d2, d3 or the constants of the equations. Similarly, delta y and delta z can be formed. On replacing c1 by c1 minus yc2 minus zc3 in delta x, we get delta x is equal to x into delta. Similarly, delta y is equal to y delta and delta z is equal to z delta. Let us consider the case 1. If delta is not equal to 0, x equals delta x by delta, y equals delta y by delta, and z equals delta z by delta. Therefore, the system is consistent and has unique solution given by above relations. If delta is equal to 0, then if delta x is equal to delta y is equal to delta z is equal to 0, then system is consistent with infinitely many solutions, and if at least delta x, delta y or delta z is not equal to 0, then system is inconsistent, that is, no solution exists. Note that in case of infinite solutions, if we have to tell the solution, then assign any real value k to any of the variables x, y or z and express the other variables in terms of k. Like z is equal to k, then x is equal to fk and y is equal to gk. Let us study homogeneous system of equations. Homogeneous system of equations are always consistent. That is, at least solution 0, 0, 0 always exists. If a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, a3x plus b3y plus c3z is equal to d3, then for homogeneous system of equations, d1 is equal to d2 is equal to d3 is equal to 0. Therefore, delta x is equal to delta y is equal to delta z is equal to 0. Case 2. If delta is not equal to 0, unique solution exists. That is, x is equal to 0, y is equal to 0 and z is equal to 0. Case 3. If delta is equal to 0, infinite solution exists. Let us study solution of system of linear equations using inverse of a matrix. Consider the system of equations a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, a3x plus b3y plus c3z is equal to d3, and let A be a matrix formed by the coefficients of x, y and z, x be a matrix formed by the variables x, y and z, and B be the matrix formed by the constants of the simultaneous equations. The system of equations can be written as A into x is equal to B, or it can be represented in matrix form as follows. Case 1. If determinant of A is not equal to 0, then A inverse exists. Given that A into x is equal to B, on pre-multiplying by A inverse and using the associative property, we get A inverse Ax is equal to A inverse B, which implies I into x is equal to A inverse V. This implies x is equal to A inverse B. Therefore, inverse of a matrix is unique. The solution obtained is unique. Case 2. If determinant of A is equal to 0, then A inverse doesn't exist. We calculate adjoint A into B in that case. If adjoint A into B is equal to O, where O being the 0 matrix, then solution doesn't exist. That is, system of equations is inconsistent. If adjoint A into B is not equal to O, then the system either has infinitely many solutions or no solution. Let us have an example. Solve the system of equations 3x minus 2y plus 3z is equal to 8, 2x plus y minus z is equal to 1, 4x minus 3y plus 2z is equal to 4. Let us have the solution. Writing the system of equation as Ax is equal to b, and then finding the determinant of A is equal to minus 17, since determinant of A is not equal to 0, thus A inverse exists. Now A11 is equal to minus 1, A12 is equal to minus 8, A13 is equal to minus 10, A21 is equal to minus 5, A22 is equal to minus 6, A23 is equal to 1, A31 is equal to minus 1, A32 is equal to 9, and A33 is equal to 7, where capital Aij is the minor of Aij. We know that A inverse is equal to adjoint of matrix A divided by 17. Also, adjoint of matrix A is the transpose of the matrix formed by the minors of matrix A. Therefore, A inverse is equal to the matrix formed by the transpose of minors of matrix A divided by 17. Since A into x is equal to b, therefore x is equal to A inverse b, where x is a matrix formed by the variables of simultaneous equations. Therefore, on simplification of the matrix form, we get x is equal to 1, y is equal to 2, and z is equal to 3. Let us have an example. For the system of equations, examine the consistency 3x minus y minus 2z equals 2, 2y minus z equals minus 1, 3x minus 5y equals 3. Let us have the solution. This system of equations can be written in the form of Ax is equal to b, where A is a matrix formed by the coefficients of the variables x, y, and z. X is a matrix formed by the variables x, y, and z, and B is a matrix formed by the constants of the system of equations. Now, since determinant A is equal to 0, therefore A is a singular matrix. Now, we find the adjoint of matrix A, which is the matrix formed by the transpose of cofactors of the elements of matrix A. Since adjoint A into B on simplification is not equal to a null matrix, thus the solution of the given system of equations does not exist. Hence, the system of equations is inconsistent.